By 2040, every new diesel lorry sale in Britain will be banned. 81 electric lorries were sold in the first quarter of 2026. The mathematics are brutal. Britain needs to eliminate 400,000 diesel trucks and replace them with vehicles that barely exist yet. Vehicles with half the range. Vehicles that cost twice as much. Vehicles that need a charging network that's measured in dozens of installations when the government's own analysis says thousands are required. And the deadline isn't flexible. This isn't a technology problem. It's not a money problem. It's a collision between political ambition and physical reality. One side is counting down on a calendar. The other side is constrained by the laws of physics, the limitations of battery technology, and the economics of an industry running on razor-thin margins. Britain's about to discover which one bends first. Operating out of their Hinckley hub in Leicestershire, DPD runs test routes with MTGX, electric articulated trucks. These trials represent the cutting edge of British electric haulage. The trucks carry full loads, including testing with double-decker trailers along predetermined motorway corridors, testing real-world performance against laboratory promises. What they're finding tells the entire story of Britain's electric transition. Range anxiety becomes range reality when you're pulling a fully loaded 44-ton rig up the M74 toward Glasgow. The ETGX promises around 500 kilometres on a single charge under optimal conditions. But optimal conditions don't include harsh winter weather, full double-decker payload, and steep motorway gradients at 60 miles per hour. In practice, drivers often see a significant drop in range before they need to find a plug. Compare that to a traditional diesel Arctic that can run over 1,000 kilometres on a single tank. The mathematics are brutal. Where a diesel driver completes Birmingham to Edinburgh in one push, the electric driver needs charging stops. Each stop requires finding a charging hub with available high-power connections. Each stop adds substantial time to the journey. Each stop costs money that doesn't exist in current haulage margins. Amazon has added Mercedes-Benz e-Actros trucks and Volvo FM battery demonstration program. These aren't publicity stunts. Amazon moves more packages per day than Royal Mail. If electric haulage works anywhere, it should work in Amazon's meticulously optimized logistics network. They have predictable routes, known depot locations, and the capital to install private charging infrastructure. Even major logistics networks are discovering the hard limits of current electric truck technology. The battery packs in these vehicles are incredibly heavy. While the UK government grants electric trucks a 2-ton gross weight allowance to help offset this, that weight still eats into payload capacity. A standard diesel Arctic can legally carry up to 29 tons of cargo. Its electric equivalent often sacrifices up to 2 tons of capacity to carry the batteries required to move it. For companies that measure efficiency in grams, losing payload per truck is like losing money on every load. HIVED ordered 11 Mercedes-Benz e-Actros trucks to expand their all-electric network into middle-mile logistics, collecting from retailer warehouses for intercity deliveries. Middle-mile logistics offer predictable routes and scheduled depot stops, which should be the perfect application for electric commercial vehicles. But making the economics work reveals why even the most suitable applications struggle with the current transition. An e-Actros 600 costs well over £250,000. A comparable new diesel-heavy truck costs around £100,000. That steep price premium means operators need each electric truck to generate significantly more revenue or last much longer to break even. But electric trucks have unproven longevity and unknown resale values. The business case requires faith in technology that hasn't yet proven itself at scale. This is where government intervention attempts to bridge the gap between economics and policies. The Zero Emission Truck Grant now offers up to £81,000 off the purchase of the largest new electric HGVs. That covers a portion of the vehicle cost, funded by taxpayers who may not realise they're subsidising corporate logistics. Even with maximum grants, electric trucks cost significantly more than diesel equivalents. The grants reduce the premium, but don't eliminate it. Meanwhile, the depot charging scheme offers up to £1 million per organisation to cover up to 70% of the costs to install charging infrastructure. British businesses are being paid substantial sums to adopt technology they struggle to justify on commercial grounds alone. the infrastructure challenge extends far beyond depot charging. Electric HGVs require ultra-rapid chargers delivering 700 kilowatts or more to minimize downtime. These aren't the 50 kilowatt chargers you see at motorway services for cars. They're industrial installations requiring substantial grid connections and specialized equipment. Britain currently has roughly 92,000 public electric vehicle chargers. The vast majority deliver less than 100 kilowatts. The number of ultra-rapid chargers suitable for HGV use is measured in dozens, not hundreds. The government's own analysis acknowledges that widespread electric HGV adoption would require thousands of strategically located charging hubs along Britain's major freight corridors. Building this infrastructure isn't just expensive, it's slow. Grid connections for high-power charging can take 12 to 18 months without early planning. Planning permissions add further delays. Meanwhile, the 2040 deadline approaches whether the infrastructure exists or not. The payload penalty reveals a deeper problem with current battery technology. Every kilogram of battery weight reduces cargo capacity. Electric trucks need larger batteries for longer range, but larger batteries steal more payload. Hauliers face an impossible choice between range and revenue. Some operators are discovering that electric trucks work for specific applications, but fail in others. City centre deliveries with predictable routes and nearby charging work reasonably well. Long-distance trunking between distribution centres encounters the brutal reality of range limitations and charging time. The range problem isn't just about distance, it's about reliability. A diesel truck that promises 1,000 kilometres will deliver 900 kilometres even in worst-case conditions. An electric truck that promises 500 kilometres might deliver significantly less in winter weather with a full load. The difference between promise and delivery determines whether loads arrive on time or sit stranded on motorway hard shoulders. Charging time compounds the range problem. Diesel trucks refuel in minutes. Electric trucks charge in hours. High-power charging reduces the time but never eliminates it. Every charging session removes the truck from productive service. In an industry built on tight margins and just-in-time delivery, downtime costs money that many operators can't afford. The maintenance story appears more promising initially. Electric trucks have fewer moving parts than diesel equivalents, no engine oil changes, no diesel particulate filter regeneration, no turbocharger maintenance. Electric motors are mechanically simpler than internal combustion engines, but simplicity in one area creates complexity in another. Modern electric trucks are controlled by sophisticated software that only manufacturer-authorized technicians can service. The diagnostic equipment costs tens of thousands of pounds. The training takes months. Many independent workshops that currently service commercial vehicles lack the equipment or expertise to work on electric trucks. This represents the end of something fundamental to British truck culture. A Gardner 6LX engine or a Leyland 680 was something a skilled mechanic could understand, maintain, and rebuild with standard tools. Every component was mechanical and visible. Troubleshooting involved listening, feeling, and looking rather than running software diagnostics. Electric trucks exist in a sealed digital environment. When something goes wrong, you don't rebuild the motor or adjust the injection timing. You replace the battery pack or update the software. The intimate mechanical knowledge that kept classic British lorries running for decades becomes irrelevant. Independent mechanics who have maintained truck fleets for 30 years suddenly find their expertise obsolete. The workshops that rebuilt engines and fabricated parts face a future where service work requires manufacturer authorization and proprietary tools. An entire skilled workforce built around mechanical aptitude discovers that electricity flows according to different rules. This transition affects more than just maintenance. It represents a fundamental shift in how vehicles relate to their operators and maintainers. Diesel trucks can be repaired almost anywhere with basic tools and mechanical knowledge. Electric trucks require specialized facilities and manufacturer support. Operators gain efficiency but lose independence. The charging infrastructure problem extends beyond quantity to location and timing. Electric trucks need charging where drivers take their mandatory rest periods. This isn't always where charging infrastructure exists. Motorway services weren't designed for articulated vehicles that need long charging times. Installing truck charging hubs requires substantial space for multiple vehicles plus supporting facilities. The locations need grid connections capable of delivering megawatts of power simultaneously. They need planning permission for industrial-scale electrical installations. They need business models that generate revenue from vehicles that charge slowly and infrequently compared to cars. The government's 2040 deadline applies to new vehicle sales, not existing fleets. Trucks typically operate for 10 to 15 years. A diesel truck purchased in 2039 could legally operate until the early 2050s. This creates a transition period where electric and diesel trucks compete on the same routes with very different operating characteristics. During this transition, electric truck operators may discover competitive advantages in specific niches, urban delivery zones that restrict diesel vehicles, contracts that value zero emissions over low costs, routes that match electric truck capabilities perfectly. These advantages could drive adoption faster than government mandates. Alternatively, the transition could reveal that electric trucks simply don't work for substantial portions of British haulage. Long-distance work, rural deliveries, time-sensitive shipments. Applications where the physics of current battery technology cannot compete with liquid fuel energy density. For enthusiasts of classic British lorries, this transition represents the end of an era. The Gardner engines that powered generations of hauliers won't be replicated in electric form. The mechanical symphony of engine brakes and turbo whistles will disappear from British roads. The skills needed to maintain and rebuild these machines will become historical curiosities rather than valuable trades. But perhaps something new and equally fascinating will emerge. Electric trucks offer instant torque and nearly silent operation. They could transform how goods move through cities and countryside. The software that controls them could optimize routes, predict maintenance needs, and integrate with logistics networks in ways mechanical trucks never could. The question isn't whether electric trucks will work eventually. The technology is improving rapidly, and the government commitment appears absolute. The question is whether the transition timeline matches reality on British roads, whether the infrastructure can be built fast enough, whether the economics work for operators whose margins are already thin. Looking back from 2050 at the diesel lorry era, will we miss the Fodens and ERFs the way people already miss steam lorries? Will the mechanical complexity that defined British truck building seem quaint or sophisticated? Will electric trucks prove better in ways we can't yet imagine? Or will they represent a costly detour from technologies that actually worked? The transition is happening whether British haulage is ready or not. The deadline is set, the grants are available, and the pressure is mounting. What remains to be seen is whether reality bends to accommodate political ambitions, or whether political ambitions adjust to accommodate reality. Either way, the rumble of diesel engines that has soundtracked British commerce for 70 years is counting down to put to silence